Welcome to this explainer. Okay, so if you've ever stared at the acronym OILRG scribbled on a chemistry chalkboard, you probably know it's a clever little trick to remember the absolute fundamentals of chemical reactions. Oxidation is loss, reduction is gain. Today, we're going to totally break down those rules, but more importantly, we are going to conquer the notoriously confusing role of agents in these reactions. Seriously, if you've ever found yourself completely tangled up trying to figure out what's being oxidized, what's being reduced, and how on earth that relates to oxidizing and reducing agents, you are in the exact right place. We're going to make this incredibly easy to understand, relying strictly on the science and unpacking the mechanics step by step. Part 1. The rules of redox. Let's establish our baseline concepts. So let's look at the big picture for a second. When you hear the term redox, which, by the way, is really just a perfect mashup of reduction and oxidation, it simply means that these two processes are happening together in one single reaction. They are an absolute package deal. You literally cannot have one without the other. If something is gaining, well, something else has to be losing. They occur simultaneously, locked in this continuous chemical dance. And this setup perfectly shows the totally inverse relationship we're dealing with. On one hand, we have oxidation. By definition, oxidation is the gain of oxygen or the loss of hydrogen. Now shift your focus to reduction. It is the exact opposite. Reduction is the loss of oxygen or the gain of hydrogen. If you can just memorize this mirror image relationship, you've honestly won half the battle. Oxidation is gaining oxygen, reduction is losing it. All right, moving to part 2. A reaction in action. Let's see what redox actually looks like in the real world. Take a look at this classic chemical equation. We're kicking things off on the left side with CuO. That's our solid black copper oxide. And it's reacting with H2, which is hydrogen gas. And through this reaction, they completely transform, pointing us directly to our products, solid copper, which is now shiny, and liquid water. I like to break this down like a microscopic heist. Just picture that oxygen atom physically moving. Step 1. The black copper oxide loses its oxygen. Because it experienced a loss of oxygen based on our baseline rules, it is reduced, leaving behind that shiny copper. Step 2. That oxygen doesn't just disappear into thin air. The hydrogen gas snatches it up. Because the hydrogen gains oxygen, it is oxidized, transforming into water. The copper oxide lost, the hydrogen gained. That's your redox package deal in action. Part 3. Mastering the agent trap. It's time to conquer the most confusing concept of the whole shebang. So it sounds completely backward to say the substance oxidized isn't the oxidizing agent, right? Well, mixing these two up is actually the #1 mistake students make on CBSE exams. It is the ultimate trick question. When a test asks for the substance oxidized versus the oxidizing agent, our brains naturally just want them to be the exact same thing, but they aren't. Let's decode exactly why that is. The paradox at play here is honestly fascinating. On the left side of our breakdown, the substance oxidized is hydrogen, because, it gained the oxygen. But look at the flip side. The oxidizing agent is the copper oxide. Why? Because an agent is the thing that actually causes the action to happen to something else. Copper oxide acts as the oxidizing agent because it causes the oxidation of hydrogen by sacrificing its own oxygen. By giving up its oxygen, it empowers the hydrogen to become oxidized. And the crucial takeaway here is that it works the exact same way for the reducing agent. Check out how the substance reduced was our copper oxide, right? Because it lost its oxygen. But the reducing agent is the hydrogen. Hydrogen acts as the agent of reduction because it actively rips that oxygen away from the copper oxide. By removing the oxygen, the hydrogen literally forces the copper oxide to be reduced. The agent is always the instigator. The substance oxidized is the reducing agent, and the substance reduced is the oxidizing agent. It's a perfect flip. And that brings us to the ultimate test. We've established the foundation, we've watched the oxygen physically change hands in our little heist, and we've finally decoded that tricky inverse logic of the agents. To wrap up this explainer, I've got to ask you, based on the rules we just covered, are you ready to test yourself on the exact CBSE exam format? Remember the rules of the heist and the paradox of the agents. If you can master who is stealing what and spot the ultimate instigator, you're ready to tackle absolutely any chemical reaction the universe throws your way.